Okay, this question here, guys. How many protons are there in 6 grams of nitrogen gas? Avogadro's constant is 6.022 times 10 to the 23. 1 mark. Pause the video. Have a go. All right, I'm going to go through the explanation. So, look at nitrogen. What's its formula for nitrogen gas? Is it N or is it N2? Well, of course, it's diatomic. So, the formula for nitrogen gas is N2. So, what do we need to know here? Well, we've been given the mass, right? We've been given 6 grams, that's the mass. And we've also been given Avogadro's constant, okay, which is the number of particles in a mole. And we've been asked to find how many protons are in 6 grams of nitrogen. So, there's an equation for Avogadro's, L, Avogadro's constant, and it is number of particles is equal to moles times L. And then we've been given the mass, and you know there's an equation, mass over mR times moles. So you see the link, the N, the moles is the link between the two. So first of all, we can find out the mass of the nitrogen, 6 grams over 28. Why 28? You've got two nitrogens. Remember, the mass of one nitrogen atom is 14, or 1 mole of nitrogen atoms is 14. So we're going to do 6 over 28. That means that we have got 0.2143 N moles. N is the kind of link between the two equations. So now we're going to times N by L to get the number of particles. 0.1243 times 6.022 times 10 to the 23, which is L, gives us 1.29 times 10 to the 23. A lot of people are going to make a mistake here and put A. A is the correct answer. But of course, A isn't the correct answer because the question asks for how many protons are there. Now, how many protons are there in each of those 1.29 times 10 to the 23 particles? Well, they're N2 particles, and each one has 7 protons, but there's 2 in each particle because it's a molecule. So there's 14 protons in each one. So we need to times the number of particles by 14 because each nitrogen molecule has 14 protons. So we go 14 times 1.29 times 10 to the 23 and we get C. 1.8 times 10 to the 24 is the correct answer. I hope that helps.
You're still here? It's over.